So we have Carl Pezer from ARM with tinyML, the intersection of hardware and software, and the shift left of algorithm development. Thank you so much, Carl. The stage is yours.
Thanks, Olga. Yeah, welcome everyone. Thanks for joining. Definitely hang out because the ARM Hangout will be right where you're sitting now in this room. And welcome to this chat. This is tinyML, the intersection of hardware and software and the shift left of algorithm development. I'm Carl Feeser, ARM AI ecosystem evangelist, and welcome everyone to the tinyML Summit 2021. I guess halfway of it, so you've already done half. So you've all probably seen this slide before. If you've come to any of the meetups, if you haven't been in any of the meetups, definitely go to the meetups as well. This is just the summit is just one big part of the tinyML community. We typically put this out in front of each talk. This is going to be one of the topics I want to come back to, not only for its own sake, but I think more importantly for anybody who is watching this in video form later and isn't physically time-based at the summit. If you're watching this much later and you don't watch this live, we're all doing something correctly. So at ARM, I'm gonna not do any product placements, but I do want to do some kind of talk about how we view tinyML and how we interact with the tinyML community. So at ARM, we try to see the ecosystem as a whole. We have some input into it in terms of our main business line being development of IP and licensing it to our partners. However, if this is all we did, it probably wouldn't work well for us or anybody trying to develop on our IP. So we try to keep that connection externally in order to aid the ecosystem. So a very important part of our overall strategy when it comes to the machine learning ecosystem at large is our AI ecosystem partners. And this is the partners making the hardware, our software partners in the ARM AI partner program, and just kind of anybody out there who's enabling the end user. So I want to take a moment to talk about that and dive into what we think of that. So what is an ecosystem? It's in my title. I should know about it or talk about it. But fundamentally, what is it? There's many different definitions, but really it's just a sum that is greater than its parts. And that's how we like to see it at ARM. The way I like to think of it is more of a natural ecosystem. It works very well, especially for machine learning, since machine learning is based on biomimicry. Well, why don't we just do that with the ecosystem? So this is an ecosystem. I like using the natural ecosystem. This is a marine one. Personally, I like this because I did a little bit of marine biology studying in school, and I just got scuba certified just because it comes with your own air, so you don't need to worry about anything that's contagious and out there. But this is a marine ecosystem, and it's natural, and it's diverse. And the marine one I really like because you can actually see it because it's more colorful and vibrant if it's a healthy ecosystem and it's bigger. So it's very expressive in terms of how healthy it is or unhealthy it is. So this is the tinyML ecosystem as we see it. We have all these partners and there's all these frameworks and tools and hardware, and they all kind of exist in the same space. They all fill their own little niche. So there's researchers too. It's many different types of companies and hardware providers. And the important part about this is that there's so many different niches that there's room for everybody. I think the important thing to realize is that there's still even more yet room to coming up, and we're going to be welcoming, and we are. So like tinyML and Raspberry Pi just did a good talk around the Raspberry Pi Pico. Awesome board to get started with. I like seeing all the new things coming out this year. There's new hardware, there's new software, there's new tools. There's big frameworks, so TensorFlow is obviously really popular, but there's going to be more of these, and that's a good thing. Each can have competition inside this ecosystem. Like there's a lot of companies here that are kind of in their own little niche, but that diversity is part of the strength. Okay, so all of this, trying to boil it down into some kind of key takeaways. These are just observations. and kind of how we think about it from my team specifically at ARM, but also a little bit of ARM in general. So we focus and evangelism specifically is enablement of the ecosystem at large. So we have to break it down and kind of how do we think about it? What do we focus on? And where do we see the trends going? So this is where I see things going this year and in the future, kind of where we are now and where are we going to be. None of these are new for 2021, but I have seen growth in all three of these recently, and in the past, and these things definitively enable tinyML in like development. The first is going to be ease of use, and this is probably the most important one because we always want new people coming in, and we want people solving their own problems as much as possible. Like if you have to go, if the learning curve is too high, we're kind of excluding people, and we don't like that. Nobody likes that. So everybody here is literally making tinyML easier to do. There's a few big things. TensorFlow Lite Micro, definitely way easier than it used to be. There's more examples. There's courses now. There's the Introduction to Embedded Machine Learning, which is free. If you haven't taken it, take a look. It's on Coursera. Then there's also the Future of ML is Tiny and Bright, and that's an edX course. Both of those are really good, kind of aimed at different levels. The introduction course is more of an introduction, and the future course is more if you want to learn how to design a network accelerator, for example, that would be a good one to start with. There's also more languages. So MicroPython is kind of making its way into tinyML. I did mention the Raspberry Pi Pico. You can program in MicroPython on that. I'm seeing more and more boards come out with MicroPython support, which makes it easier for people coming from a more machine learning or data science side to get started with technically what is embedded programming. They just don't know it because they're doing it in Python. Let's see. Skip that, sorry. Simulation. I will get into this more later, but this is effectively cloud native practices that are moving to the edge, just like machine learning has in the past. Variation is the other one. This is kind of that diversity that I mentioned with the metaphor of the reef. So there's new NPUs, new accelerators. We just saw BrainChip talk. That's awesome. Like I like seeing different approaches to all the same problem, mostly because not everybody thinks the same way and not everybody develops the same way. So wherever you're coming from, there's probably now an answer for you to get started with tinyML. There's new frameworks. So micro-TVM is still, I would say, a research project, but it does exist. So there is some kind of alternative. New algorithms, new approaches, more providers, more hardwares, lots more accelerators this year. That's really good. I like seeing that. And more developer boards is probably my favorite thing. That's the most important part is wherever you're coming in from, there's probably an answer. So diving deeper into simulation and what I mean by cloud native practices, I kind of see this as inevitable, like gravity, kind of this collapse of the cloud to the edge, which is happening just like it did with machine learning in general. We're now seeing it with all these other practices. I will go a little bit, basically you're seeing what used to need a GPU, now you can do it on a microcontroller. And we're seeing that in terms of practices as well, like development practices. So this is kind of a shift left in practices. If you're not familiar with it, shift left basically means you release early. It's more of a design thinking or a software strategy. So release early, get it out the door, get feedback, iterate quickly. So we're seeing this in tinyML now with the newer technologies. And ARM is working in some of these ways, but a lot of these are just things that are happening in the ecosystem. Fundamentally, it just means get it out there quickly and get started as quickly as possible and get feedback early. So this means that the end user, A, has a better experience, and B, can probably get up and running as quickly as possible. There's a few ways I've seen this happening. The first is IP Selection Sandbox. This is the only one that's ARM specific, but this is effectively a tool that you can use to pre-configure your IP. And now we have it running so you can actually test out some workloads in the cloud, specifically for the NPU, and that is available for free. And you can test it. You just need to sign up with a developer.arm account. You need to request access for it, but you'll get it in a few days. So you can test it that way. You can test a model, see how well it performs on our hardware in terms of before it's even conceivable of being existing in the world. So check that out if you're curious. Renode is another big one. So if you're not familiar with it, Renode is an open source tool built by Antmicro used to simulate IoT applications. So if you're already familiar with it, this is probably going to be the most one. This is the one that's most specific to you, and you will probably like this one the most. There's machine learning examples on Antmicro's GitHub, so you can go out there and test, do tinyML in a simulated environment, even an entire simulated IoT system. It means you can get going quickly as possible without even needing hardware. That same FVP, the M55 for evaluation that's in IPSS, is also used here. So this pull request was from some of our engineers to add more Cortex-M targets for it. So you can go test the FVP for the M55, and that again is not even physically out yet, but you can test it now and with Renode and see how you can develop with it. Docker is the last way. This one also is probably my favorite, and this is probably also not complete. I'm sure there's other people doing this in other ways, but this is just what I've seen. Yes, Docker. So this is also the newest one, as in just yesterday another Docker image was put up. So this hopefully will get better. There's a caveat, as in we are working with this and just started working with it. So if you work with it now, it might be changed in a month, and in a month it might be better, but it does exist. And if you want to use this and try it out, you should. If you're familiar with Docker, if you really like it, if you really just want to try out an M55 very, very quickly, see what it's like, you can do that now. And that leads me to the conclusion and what's next, and what are the important things to take away that I went through. I'm going to ask, while you're attending this conference and for the rest of the week, to keep a few things in mind. How can what you're building be made easier to use by someone new, and who's your target audience? That's mostly just because the tinyML community is still relatively small, and so we kind of all have to be our own evangelists. Like, we've had a lot of growth, but we want more growth, just because tinyML is a great enabler. Even if it's cutting edge research, see how it can integrate with something that already exists out there, and because more than likely it'll make it easier for you to develop with it. It'll also make easier for someone else to follow. Finally, I just want to say, keep going and keep doing and keep coming, and go to the summit, come to the summit, take a class, go learn something new, develop code, go to the meetups, go teach somebody else. Just because everybody has their own approach to this, and that's very, very good. We want to see as many different approaches as possible, because being able to do machine learning on the farthest edge is this huge enabler. It used to need like a PhD and a research farm and a data lake, and now you can do it in the palm of your hand in 20 minutes from your computer at home. So keep doing it, keep going out, join the meetups, start your own meetup, go do a talk, go learn something new, and go build something. ARM will keep supporting you however we can. Thank you.
Again, just a quick shout out to our sponsors. Bear with me for 1 minute. We have different categories. We have executive sponsors. First one being ARM. Then we have Qualcomm. We have Samsung. Platinum sponsors. Ada Compute. Lattice Semiconductor. Gold sponsors. BrainChip. Babel Labs. DSP Group. Edge Impulse. EMSA. Gray Matter Labs, Green Waves, HiMax, Imagimob, Latent AI, Maxim Integrated, Quixo, Reality AI, SensiML, Silicon Labs, Sentient, Google TensorFlow, XMOS, and lastly, silver sponsors, Edge Cortex, Hotchi, and Synsense.